sometimes when we're working with Rust and we have options, we don't want to just have a bunch of unwraps. There's this sort of unspoken rule in Rust that we just use question marks everywhere instead of unwraps for result types. But then if we have option types, we sort of like, once again, potentially have to do a bunch of unwraps. Now we could do a bunch of like if let sums to like extract out the contents, but what if we know that these are going to be exactly what we want, or we want to do something better, which is converting the option to a result? Then we can just do a question mark. That's what I want to show you in this lesson here today. So let's go ahead and create a function that's going to return an option here. So function this, let's see, let's call this like maybe something. And we're going to return an option, and this option can potentially have maybe like a U32 inside. Okay, but of course, just because, you know, of reasons, it just always returns a none. It's like nothing. Okay, so if I want this function to be able to do, like normally what I have to do to get this out is, especially if I know that this is going to be a something as opposed to a none, is I would have to do a let my something equals maybe something dot unwrap. And if I do this and we run the test, we're actually going to see it crash because we unwrapped on a none value, which makes total sense. When you unwrap on something that's a none, you want it to crash. That's kind of the expected point. But what if we wanted to use a question mark here? So let's say we pull in our error result, and I just want to be able to do this to it. I just want a question mark, which basically means that if this is an error, also let's go ahead and return an okay. If this is an error, I want you to just return up, and then something else, probably closer to the main file, is going to handle that error and then print out what it is. But then here in this function, we can just focus on the happy path. Hey, if this is something, then we're going to grab that out and then do something with it. Okay, but the problem is that I can't actually do that here because this is attempting to question mark on an option. That doesn't work, especially if I'm returning a result here, because we're doing other things that actually do return results. Okay, well, let's take a look at what methods we can actually call on options. So here I am in the standard library documentation, and there is some methods over here, okay or. And we have okay or else or okay or. Both of these are meant for converting options to results for us. One, the okay or is going to convert it greedily, so it's going to do compilation step and compile it to figure it out at compile time, and the okay or else is going to wait until runtime to do that sort of calculation to figure it out. I have Clippy installed and set to its like highest value, so I just usually just do okay or, and then if Clippy yells at me, I just have it automatically switch it over to okay or else, and I don't have to worry about it at all. Which is one of the nicest things about having advanced tooling. Okay, so how do I actually convert this into a result type here? Well, first of all, we're going to have an error to use here. So let's go ahead and create one really quickly using the information that we got from this error. And I still have this error installed. So what I can just do is we're going to create an enum errors, like some error, and something was nothing. We have to have a display. Something wasn't really something. Turned. out to be nothing. Okay, and then we're just gonna derive a few things. We're gonna derive debug and this error. All right, I believe that's gonna make that happy. And so now we can finally set ourselves up to have this be an actual error here. So we're gonna do okay, or, and then we're just gonna pass in what this error should be. So we're gonna do error, and then it's gonna be this custom. I actually think it doesn't need to be an error like that. I think we could just do this custom error like that. Something was nothing. And now you notice it's still trying to return this result right here. So now I can question mark this. And it shows that, hey, you have the U32 here. We're training this custom error. This is then being wrapped into that error and then returned with a question mark here. And everything is fine. Everything is really happy now. I can at this point do an assertion. So assert equal that something is equal to, I don't know, 42, 52 apparently. Now this will never get here because we're going to exit out because of this none here at this time. So if I run you, we get a panic, but it panicked because somewhere else. It panicked up above this function here. If I actually take a look here where it panicked, on line 5, because we returned this error type, it then went up to a parent, which is in the actual Rust library itself that's dealing with the assertions and saying, hey, in this test here, you returned an error. In our code, it would then give us a stack trace for the code, for the actual line of code here, and then also give us this display of what displayed out. Okay, that makes a lot of sense. What if it was actually something now? So we don't return a none, we return a sum with a 52 inside. And if I do that and we rerun our tests, everything is fine and the test pass. And that's because we have successfully converted over. Now, what does okay or else look like? Because it's like subtly different, because this is greedily evaluated. It's gonna run this code, turn it into the error, and essentially put it in here behind the scenes. If I use okay or else, then what this takes in is the equivalent of a callback function, otherwise known as a closure in Rust. And closures always take vertical pipes to sort of denote what the arguments coming in are. But of course there are no arguments here because it's a none value, it's an error. So we just do these vertical bars and then what the return value is, which is gonna be the error itself. So that's the only thing we need to do. Now notice here, Clippy is yelling at me because it's saying, hey, this is like, you don't really need to do this. This is unnecessarily lazy evaluation. What I can do is hit Control dot here, and then Clippy is going to, with Rust Analyzer, just auto convert my code over to what the best practice is. And so that's why I usually start with just an okay or, and then wait until Clippy yells at me. And if I did something more complicated, then Clippy would definitely try to have me use an okay or else. All right, well, that's how we can convert an option to a result, which can clean up our code and allow us to use a little bit more of a question mark here and just make sure that we have good error messages that are being passed up to whatever central error handling system that we have. Probably some match on a on like the call to the main library in the main function. So with that, hope that this is helpful, and I'll see you in the next video. Bye.